here's an example of a what? You should know the word. Ogive or cumulative frequency plot. Okay? A cumulative frequency plot typically has this very distinct S shape. And last class, if you remember, we made one, right? And I think that's about all we got through was making one. An ogive. Okay? We made, I think it was plant heights or something like that. Okay? Well, here's a different example. Okay? And it says, let's read it here. I'm going to pause the recording while you read it, and we're going to ask some very specific things or answer some very specific questions here. And this is actually from an IBSL textbook that I stole from, but same concept can be used here. Now, the one that we did last class had the cumulative relative frequency along the left-hand side, didn't it, I think? And I told you it could be written in both ways. It could be written as percentages, 0 to 100%, or we can just have the actual cumulative frequencies. So in this case, because there are 80 senior students, the top number does go to 80. It's not percentages, and that's okay. Well, we have to make sure we pay attention to that, because I have seen it in both ways, okay? It can be in percentages or it can be in numbers. So we're looking for the median, okay? Where would the middle number be? 50%, which would correlate to what number here? 40, okay? Half of 80 is 40, right? 50%. All right, so what we're going to do is we are going to make this as thin as possible. Let me remember how to do that. I think it's here. All right, so now we're going to try to make it purple. Let's see how this works. So the median, because it's 80, the median is the 50th percentile, if you want to think about it that way. And it does correspond to the 40 in this particular data set, because half of 80, right? So we're going to go over here, we're going to go on 40, and I really want you to use a straight edge when you do this. A great straight edge is the corner of your paper, okay? So I'm going to borrow Brenda's paper for a minute. You can line it up with the 40, pretend like it's, and then just kind of line it up, line the corner of your paper up where it touches the graph and draw a line straight down, okay? We want it to be as exact as possible. My smart board is supposed to make it straighter. Anyway, pretend, okay? And then we're going to go straight down. That is where the median lies, so we should be able to physically count it at this point. So 55, 56, 57, 58, 59, oh, nope. I think it goes up by twos. What do you think? Let's try. So 56, 57, 58, 59. Yeah, it goes up by twos, right? So we have 57, I'm sorry, 56, 57, hang on, 55, 56, 57, 58.5.
Yeah, no.
It's not about, it's exact. I know, it's hard, it's probably easier for me to see because I'm really close to the paper, okay? But you're going to create your scale here. You need to be exact, okay? And I will give you a scale, like a grid on the back for you to help you, okay? When needed. So are we okay with the median? Any questions about where that came from? All right, how about the interquartile range? So I'm looking for Q3 and Q1. What do those correspond to in terms, if the left-hand side was a percent, wouldn't it be 25 and 75%? Okay, so we need to find 25 and 75% of 80.
20 and 60.
Good, so 20 and 60. But sometimes these are easy numbers, right? They might be like, what if I did 53 senior students? You have to know how to find 25% of that number. And I'm sure you know how to do it, but I'm just going to remind us. So we can say 25% of 80. That's how you do it, but he's right. And we can do 75% of 80. And it is 20 and 60. So I'm just going to use a different color here. I don't care what color. Let's try blue. So we're going to say 20. And I absolutely want you to draw those lines in for me so I know that you know what you're doing, okay? And then we have 60. We'll do the same thing. Again, using the grid lines of your paper, okay? So remember that we're always using the numbers on the horizontal scale, right? So let's see. So this is going to be 55.5. Good. And this one is 61.5. Very good. So if we're going to go ahead and subtract those, and we get what? Good. All right. So the interquartile range is 6. Good. Okay. How about letter C? We want to talk about the top 10% of runners. A lot of times you guys talk about the top 5% of your class, or you're the top 2% of your class in terms of colleges, or looking for those kinds of things, right, when you're applying to colleges. So how do I find what is the top 10%? What number on the vertical axis would correspond to the top 10%? It's definitely higher. It's in the 70s. How'd you get 72? Perfect. Top 10% is the 90th percentile. Would you agree with that? Top 10%, 90th percentile. So that means you say 0.9 times 80, which happens to be 72. Very good. So 72, let's see if does it go up by 2s? I don't know. So we have 60, 70, 2, 4, 6. It does. Look at that. So 72 looks like this guy here. So to me, that looks like 64, right? So 64, what are the units? Does it say? Seconds. So we want to make sure. So 64 seconds corresponds to the top 10% of runners, or we could also say that it's the 90th percentile. Okay? You feel a little bit better now, hopefully? All right, let's take a couple of minutes. I'm going to pause the recording, and I want us to look at the first first problem that I assigned. So again, if you need to grab a textbook, go ahead and do so. So Jordan and Hunter, who says he's like, no. All right, so here's a good point. And Jordan got a blow pop because he looked at the context of this question. So Jordan, explain what you said. If you're running and you're the top 10% runner, shouldn't you have a slower speed?
Or higher speed,
lower time, higher. So that's my question. Is this time should be smaller, right?
Yeah.
So in this particular case, and this doesn't happen very often, which is why I probably didn't catch it myself, but in this particular case, he's right. The top 10% should be down here because they would have a faster speed in running. So context, very good. Yes?
Wait, can I answer my question? Like, what if you actually screw up?
You would get most credit. Okay. I don't think on the test that would be the case. It doesn't matter because it didn't ask you for the quartiles, it just asked you for the IQR. Right? You're still subtracting. Yes. Yeah. Yeah, the IQR doesn't change. The quartiles just flip. You're still subtracting them, aren't you? Okay, so what number would be the 10% of 80? So that would be 8. So let's see what it would be, okay? So let's see. You think that's blow pop worthy? All right, hang on. Shh. Go ahead and be working on that. Thank you.
I was off one day. I fall too hard. Cameron Smith.
53. You said 52. Hunter, liars don't succeed. Main thing. Can you look at the shape of the graph, like making a box plot, for example, okay, based on your ogive, and then determine the shape of the distribution? It's hard, I think, looking at the S shape and telling the shape of the graph from that. So that's why we kind of work backwards from the ogive to the box plot, and that tells us the shape. When you graph this, let me just give you the numbers as an estimate for the 5-number summary, just so you have it. I have that, or do I even have it? Okay. I have the minimum is about 31. I have the quartile 1 to be 34.5. I have the median is not on here, but we're going to estimate it to be about 36. 36. Again, it's estimate. Okay. Quartile 3 is 36.5, and the max would be 38. And again, if you're off by 0.5 or so, that's okay. It's an estimate. Here, there's no grid on the back of this, right? You can't be exact with no grid. Okay? Shh. If you were to graph a box plot, you should be able to determine that it is skewed left. It has a longer whisker on the left-hand side than it does on the right-hand side, which means it's skewed left. It also has a longer box on the left as well. Okay? Okay. I think that's really all I'm looking for. Can you do that? Good enough? Now, one thing to be careful of is that sometimes this scale has percentages and sometimes it doesn't. So don't assume that what you see is percentages. Make sure you read the problem. Okay? That's really all there is to ogives. You will have a free response question that deals with ogives on your test. Okay? Well, one with like 3 parts A, B, C. Okay? So I don't know if you count that as 1 or 3 questions, but it is a question on your test. So ask now. Do you have any questions, concerns, issues about them? Hang on, whoa, 1 person at a time. Quartile. You find, Sammy asked, how do I, just remind me one more time, how do I find the quartiles? Okay, Erica, look up here, honey. Okay, quartiles. Q1, what percentage goes to that? 25%. So what's 25% of 80? 20. That's where I got 20 from. Okay, 75% is Q3. 75% of 80 is 60. That's where the 60 came from. The min is whatever happens to well, 0 is always the starting point. Yeah, this is the actual data, right? 50% would be, oh, I'm sorry. 50 is the smallest number, smallest time, shortest time in this case. Yes, the last number represents the 100th percentile. Okay, good. All right, I think we're done talking about ogives. Again, I will look at question 36 along with whatever homework I assign tonight for the test review. Fair enough? Okay. Let's go ahead and keep going. I have a question I'd like to look at. I think we're done. We know how to compare box and whisker plots, don't we? I think we've kind of, we've tumbled that to death, I think, haven't we? All right, let's look at this question. I'm going to pause the recording. I want you to read it. And again, you can print these notes off at home as part of your review as well. Take the what? 23rd? Why can't I hear you? I'm sorry. 24. Okay, I'm sorry. 24 and divide it by, okay. I'm going to write this down. This wasn't what I was thinking, okay? And get what? 8? I'm not sure dividing it's what you want to do. I get multiplying it, though. Okay, so 24 divided by 3, and then you would say 30 divided by 2, and then you would say 22 divided by 1, and then you'd add all these up. Okay, I don't think that works. Because if you add these, add them and divide by what? Maybe, if I added them, I would get, what, 45, 55? What is it, 45? And then I would divide that by what? Where'd you get 8? It would be 6, right?
Yeah,
There's 6. What's 45 divided by 6? I don't think this is going to work. Which is not definitely the average size class. Okay. So I like what you're thinking in terms of taking each class together, or I'm sorry, each 5th grade class and looking at it from that. You know, there's 3 of those, there's 2 of these. You definitely want to go in that direction. So absolutely applaud you for that. That's perfect. The problem is you don't want to divide, okay? You want to multiply. So here's what you're going to do. There's one way to do it, and it's the easy way, I think, would just be this. You could say, okay, there's 3 24s, right? There's three 24s.
It's already me.
I understand that. There's three 24s. Okay, I wrote the problem. I do understand that. All right. Then I have two 30s. Right? And then I have one 22. Can I just add them and divide by 6? That will work. But what if I had like Prince William County Schools? This is obviously a small town. This is in like small town USA. Okay? We talk about Prince William County Schools. We have a lot of 5th grade classrooms, right? So we can't, this would be tedious to do, writing them down every time. Do you agree with that? What's a shortcut?
Same number, just multiply it.
Okay. So 24 times 3 plus 30 times 2 plus 22 times 1 if we wanted to, all divided by 6, because there's 6 classes. Would you agree with that? Because there are 3 24s, which means it's 24, 24, 24? Yes, Devin?
Do we multiply because like the mean formula is divided by the number of numbers, which means we multiply the number of numbers?
What that's saying is that the mean of the means, what do you mean? That's what you're saying, right? The mean of the means is the same.
The mean equals the sum over the value.
The sum divided by the total.
Right? So
It's just that our values are means.
you have to multiply the
Basically what he's saying here is that, and this is what Zachary was saying too, is that these values are actual means themselves. That's okay. Doesn't matter. Okay? It doesn't matter. That's the point. Good? All right. These, I just want to summarize. You've already turned this in. This is parts 2 and 3, right? I just want to make sure that I have officially summarized with you. When you add or subtract, and I think we talked about it last class, but I don't think I officially wrote it down. But how does adding or subtracting a value affect the data? What values are affected? Mean and the median. Okay? I'm going to do a little demonstration to prove that. Okay? All right, so mean and median, the center is affected when you add or subtract. And to summarize, when you multiply, what's affected? All of it. You're going to take that information, and let's just kind of reiterate here the effect of, we talked about this last time, right? I said I wasn't going to grade it because it said to go from part 1, and I had your part 1, so I'm going to omit it, but we talked about it. You will have a question like this on your test, where I give you a set of data, and I said, okay, now what's going to happen? Evie?
When you want, and when it's tell how, would you have to actually give examples of numbers?
When it says tell how, you say multiply by 2. You say add 1. You say subtract 25. So tell me exactly what you're going to do to make that change. Okay? Yes? I know it was. It was a typo on my part. So because because that should say 2, I didn't want to penalize people who didn't do it because I had your part 1. So it's my mistake. But you're exactly right, Sam.
Do you explain it when you tell how the term sounds, or you don't?
Okay, so what I mean is this. Okay? Shh. Listen carefully. Come on, Erica. All right. The median's 25. What was it originally? I don't remember. Let's pretend it was 20. I'm just for giggles, okay? I don't know what it was, but let's say the original median was 20. Okay? I want to now increase my median to 25, but I don't want the range to be affected. So what would I do? And this is what I want you to tell me exactly. Calculate, tell me, add, subtract, multiply, divide by this number exactly. Amanda? I would add 5 to every number. Because when you add or subtract a number, the only thing that's affected is your measure of center. The range or the IQR or the standard deviation aren't affected. Spread is not affected when you add a number. So this stays the same, right? Okay? So add 5 in this case, okay? IQR of 18. Now, it depends on what it was originally, right? Okay? But because the spread is what is an IQR, right? So the spread's going to be changing. So in order to make the spread change, what are you going to do? Multiply by whatever it would happen to be. Let's pretend that the original IQR was 9. What would I do to make my IQR now 18? Multiply by 2. Are we okay with that? That's what I'm looking for. Does that make sense? You'll have a question like this on your test. Okay? How about C? Let's just make sure we understand, because it's two things together, right? So, think about order of operations. Should I multiply first? Should I subtract first? Should I add first? Do you have a question, Sam? Shh. Okay, let's see. If I multiply by 2 first, everything's affected, right? Everything's affected. So if I multiply both of these by 2, my new median is now 40, and my new IQR is now 9. I'm sorry, 18. Liar. I don't know what the actual was. I don't have it memorized. Evie.
I don't understand how you could just add 5, because wouldn't that like affect the rest?
Only the measure of center is affected when you add a number. Think back to our boys up here with the whiteboards. When I added a number, they stayed all the same. They just moved up. The spread of my arms didn't change. The center did, right? So if you're not going to change the spread and you only want to change the center, you're going to add. And the number you would add would be the difference of the two. Right. Okay? So down here, once I've multiplied by 2, everything's affected. Now I want my median to change, because I have the right IQR, don't I? I want my median to change from 40 to 50, so now what do I need to do? Add 10. And that would be it. Okay? All right, next. Yeah, we're done. Okay, this one I think I discussed last class, so I'm not going to go over it again, but basically a $1,000 bonus means you're adding down here, which means the only thing that should have changed are these two. These should stay exactly the same, right? Your measures of spread don't change. Down here, everything changed by a factor of 8%. So 1.08 times this would give you the answer. Stephanie, you have a question? You guys don't ask me questions like this, because I promise you I can't understand you. You're not the only one. He was doing it too. That's why I'm saying it. Down here, I don't multiply by anything. I add $1,000 bonus means I'm giving you $1,000 bucks. I'm adding $1,000 to your salary. Right. That's why I circled them. They change. Okay. Good. All right. Yes, sir.
How are you supposed to figure out what the mean is if you don't know what the rest of the numbers are?
It doesn't matter. You're going to add $1,000 to the mean. That's your new mean. Whatever you add or subtract, that's how it changes. So this would be 57,500. I just add the 1,000. Okay? That's all you got to do. All right. Let's keep going. Here's some multiple choice practice questions, because I promised you we would do those, right? So I have a couple. This is an actual multiple choice question that was released by the College Board. It talks about a histogram and a series of box plots. This should look familiar. Didn't we have some problems in the textbooks that we had to match up like this too, didn't we? And I think we did it in class as well. Okay? So, which of these box plots, A, B, C, D, or E, represents the shape of that graph? Okay? Remember to turn your head to the, in this case, it would be to the left, because that's where 0 goes, right? can you eliminate some? What would you eliminate?
E.
I would not eliminate A.
E.
I would eliminate E and D. I agree, because those are the opposite direction of skew, right? Because 0 is on the left. If I turn my head, 0 will be on the left. We want it to be in the same shape. Do you agree? So skewed right is what I'm looking for. Now we should probably look at like the measures of center, because if you look at A, B, and C, don't they all have different measures of center? Okay, so how would I find the median when I'm talking about a histogram? Well, I can look at the heights of all of my boxes and figure out where the middle should be. Would you agree with that? So this is about 47. I'm again approximating. This is about 13. This is about 2, 2, 2, 1. I'm approximating, okay, because I don't have an exact scale. If I wanted to find the middle value, I would add them up, divide by 2, and it would be between those two things. So 47 plus 13 plus 2 plus 2 plus 2 plus 1. And I get 67. That's an odd number, which tells me that we know exactly where the middle is. It's one of the values, right? Divide by 2. So where's the middle value? 34th. Because I'm finding halfway. Which is what I just did. So that the 34th data value, isn't it here? So it's in that bar, okay? So that bar is between 0 and 1. So couldn't we cross this one off for that reason? Couldn't we cross definitely that one off for that reason? So what do you think the answer is? There it is.
No,
Okay?
we should eliminate A.
I thought we were on the opposite.
Right.
But what you just taught yourself is it depends on how you turn your head. Make sure you know, do I turn left or do I turn right? Look at your scale. Well, this one you turned left.
I can't think this time decided.
Yeah, that's like.
Why do they got this far as
Because everyone can make them different ways.
Since it's skewed, like, you have to find the median instead of the mean.
I did find the median.
No, that's the mean.
That's not the mean. 33.5. The 30. No, it's not. Okay, I just simply added all these up, and those are the counts, right? Those are the number of values divided by 2. That tells me the middle. That's halfway. Divided by 2 is halfway, not the average. Okay? I'm sorry, what did you say? Definitely. Okay, let's try another one. This one's so ugly, and I apologize, but I might have to make it smaller so it's not quite so blurry. Is that worse? Is that better? I'll read it. Okay. Now this is a multiple choice question. Maybe if we just covered up the multiple choice, we could answer it better. I don't know. So it says a data of test scores is being transformed by applying the following rule. So what is the rule? Am I multiplying by something? Am I adding something? Am I doing both of those things? I am multiplying by 3.5 and I am adding 6.2. So that is kind of like the question we just went over, isn't it? Okay, this is a way we could ask it in a multiple choice format. So read one of these. Let's figure out. Yeah, if you need to come up to see, I apologize for it being so blurry. So the mean equals 3.5 times and then add 2 or add 6.2. Okay? If you're not sure, we can always go back to the ones that we created, right? So if we have a rule where we're multiplying by 2 and adding 10, right? How did I do it? If I multiplied by 2 and add 10, what happened? Okay? So I want us to think about what's going to happen to the data. Okay? So let's look at the original mean, or the median, I guess it was. Okay? The median was 20. If I multiply by 2 and add 10, do I get a median of 50? Yes. So what do you think about answer choice A here? The mean, which is another measure of center, is that true? A is true. Okay, let's go to B. The median is the same thing. True? Because it's also a measure of center. Both of those things are true. Hey, I'm eliminating answer choices. This is a strategy I want you guys to employ when you're taking a test, especially multiple choice. Cross off the obvious answer choices. Except for if you were Sammy, you'd cross off the answer in the last question. Hang tight. Okay? So let's look at C. The range is transformed by multiplying and adding. Well, hang on, okay? Because the range is affected by the multiplication. Is it affected by this? Okay? So that's a possibility that we think it might be true. Do you agree? Or that's the one that's not true. Let's go ahead. The standard deviation is just 3.5 times. Yes, because that's a measure of spread. IQR, again, a measure of spread, so it's only affected by multiplication. So these are both true, which tells me what is the answer. Does that make sense? Okay. Again, it's worded a little bit different than the way we worded it in class, but it's the same concept. Did I lose you, Kyle? Because these are all measures of spread. Measures of spread are only affected when you multiply, not when you add, so that's why it's not true. Sure, you know what? If you had enough time, Sammy, I would say sure, but it's a timed test, so you really need to know these concepts.
We're just adding the 6.2.
Uh-huh, that's what it says right here. Yep, just adding it. It's 50 a section. 50%, 50 points for your multiple choice, so each multiple choice question's worth 5 points. I know. Yeah, don't leave any blank. Definitely just guess if you have to, I guess. All right, last multiple choice question. This one's blurry again, isn't it? Ay, ay, ay. A little bit better, maybe? Sorry. Now you can't read the answer choices. Ay, ay, ay. All right, so I like this histogram because it gives you the numbers at the top of each of the bars. Do you agree? So that you don't have to estimate. It gives them to you for the heights of the bars. Remember, in a histogram, the height is always the same as the frequency, however many values there are there. Okay? So we want to figure out where the median is. Gosh, this looks exactly like the other problem that we did, doesn't it? So where would the median lie? So here's what we have to do. We have to add the heights of all the bars, don't we? Do it. You have a calculator. Add the heights of your bars.
25.
So the 13th data value is in which bar? 5, 6, 7, 12. It's right here. Would you agree? That's where the middle is? Double check me. So it's going to be between 8 to 10 years old. That's the height. You're adding these together. And then so 4, 5, 6, 7, 12. The 13th goes here. So this is where the 13th value is. Good? Are we good? All right. Maddie, you okay? I thought you said so I'm just worried. Oh, you said Erica, wait, where did I lose you?
I don't know.
Shh. Okay, because there's 25 households. 25 divided by 2 is 12 and a half. So the 13th data value. Think about it. If I have 13th data value and I have 12 last down here, I have 12 up here, right? That's a total of that's not right. It's not 12. Sorry. Helps if I can't add. Hang on. Okay. Anyway, there's 12 values down here on the 13th data values, right? No, if that is the 13th value, there's 12 lower, and there's going to be 12 higher. All right, if this is the middle, there's 12 here and 12 here. 12 plus 12 plus the middle is 25. So the 13th value is the middle. If it's an odd number, does that make sense now? Okay.
I just, like, the way I explained it to her is just like, if you add up the numbers starting at 4, 4 plus 1 is 5, and then 5 and 2 is 7, and 7 plus 5 is 12, and then when you get to 3, that's where you're going to add up, and it's going to become 15.
Yeah, I didn't understand
Right
that.
there, so
I
that's
didn't
where
know
it's going to fall.
Right.
I was just looking at the skill.
Yeah, you're adding these numbers.
13 is like, okay, we're out.
You're adding until you get to the 13th. Yes.
Okay.
Good now?
Yeah.
Okay, thank you. All right. So here's what we're going to do. We only have about 15 minutes left. I'm going to give you 2 free response questions. I'm going to it's only 1 free response question. Okay? So this is I guess we only have the one, so we'll go through it. Pretty easy. Here's a free response question. I'm going to try to make it a little bigger so you can actually read it. I'm afraid if I do that, it will get, that might be better. Okay. So I'll let you read until we get to the 2 dot plots. Notice what you see, 2 dot plots again. Okay? So read for just a second. Half the battle is just reading this and figuring out, what are they telling me? Okay? Basically, you have a launching location, and you're taking this catapult and you're slinging ping pong balls. And it has to land in this target area. Okay? So then we have some dot plots, and that's really all that picture's telling you. Okay? Then we have some dot plots. We know how to compare 2 dot plots, don't we? We know how to talk about shape, center, spread, right? Fully expect you to be able to do that. So when it says words like comment on any similarities and differences, you're going to talk about what? Shape, center, spread, right? Just like the quiz, honestly, right? What would you say? Which one has a bigger spread? Catapult A. What does that mean in context? Let's say that I'm Catapult A and Deja's parents are Catapult B. Okay? Who has the bigger spread? Miss Macker. What does that mean in context? I'm less accurate, right? My catapult is not as good, maybe. It's just less accurate. I like that. That's a great way to say it. It's more variable. Okay? I have a chance of getting some high ones, don't I? I have a chance of getting some higher launches or further launches than Deja's mom. But I also have a chance of just like a total dud, right? Okay. So down here, if the parents want to maximize the probability of having the ping pong balls land in the band, which one should they use? Why?
It's accurate.
Because B is more accurate. Would you agree with that? Next. Catapult C. I'll let you read that one. Yeah, it's. I don't want to answer it all for you, but yes. Yes. Okay, very good question. AP expects you to reply in full sentences. I was an AP grader this summer. I don't know if you guys knew that. Actually, it was last June. I left my classes for 10 days and went to Kansas City and graded AP exams. And we had to, every word you write, we have to read. I'm going to pause for a minute. Okay. So I feel like we reviewed really well today. Okay. And I think that if you really paid attention today and you really understood the concepts of ogive, comparing box and box, comparing the distributions, the concepts from the quiz, standard deviation is something that you need to talk about. How data is affected, whether you add or subtract, multiply or divide. All of those concepts are going to be on your test, okay? Question, Tanner. No, never again, okay? You had to do it once on your quiz, but on the test, no. You don't have to worry about that. I told you only once, okay? Question?
Will that be on the AP exam?
Standard deviation by hand? No.
They don't know what you do.
Who's going to take the time?
It takes too much time. It will not be on the exam. All right, so you have 2 options. Well, you don't have any options. I'm just giving you excitement. Okay, I lied. I hate when I lie. Here we go. So number 36 on page 97, I'm going to be looking at. And I'm also going to assign some problems here for, maybe I am and maybe I'm not. Okay. so your homework.
We're not doing C.
You can go back and look at it on your own if you want to. The test is on Friday. Again, 10 questions multiple choice and then several free response questions. I'm going to ask you that you, in addition to the OGI problem from before, and then I'm also going to have you do on page 137, I'm going to have you do, let me not do all the way to 137. Let me start at the review, which is at page 133. Nope. I'm a liar. All right, let's start at 134. I'm going to have you do 17. I'm going to have you do, we're going to skip around 24, 29. They're just banging into the wall. And 34. Okay. This in no way is comprehensive of what you will see on your test. It's simply just some questions as part of your review. Definitely look at your quiz and anything that we did today. I will, sure.